Everyone, we will solve this today's LeetCode problem. The question is find valid matrix given row and column sums. So the question is LeetCode medium. Let's see. We have given our two arrays, row sum and column sum of non-negative integers, where row sum I is the sum of the elements of the ith row and column sum j is the sum of the elements of the jth column of a 2D matrix. Fine. In other words, you do know that the elements of the matrix, but you don't know the sums of each row. Okay, we don't know the elements of the matrix, but we know the sums of each row and the column. Fine. So basically, we need to find any matrix of non-negative integer of size, row sum length, into column sum length that satisfy the row sum and the column sum requirements. Return a 2D array representing any matrix that fulfill the requirements. It is guaranteed that at least one matrix that fulfills the requirement exists. Okay. Okay. So basically, the given is we have given a row sum, right, and we have given a column sum, right, in this vector, and a particular row sum I is representing the all elements, sum of all elements of ith row, and same for this is for ith row, and same for goes to column sum, right? The same goes for column sum. That this ith is representing the sum of all elements of the ith column, right? This is we have given, and we need to find the matrix, find the 2D matrix that can satisfy this row sum and the column sum. What does it mean? It means the ith row sum should be, we will need to choose the integers such that in the matrix such that the sum of elements of the ith particular row should be row sum I and the column sum I as represent, right? That's the question we need to understand, right? If we see the first example, this 3 8 and 4 7, this 3 8 and 4 7. So basically, if you see that how can we make a matrix so that this satisfy 3 8 and 4 7. So basically, this 3 is a summation of first row, right? First row sum is 3, second row sum is 8, first column sum is 4, and second column sum is 7, right? This is given. So how we will form a 2D matrix of size? So this, see, row sum is 2 and column sum is 2. It means we need to form a 2 cross 2 matrix for sure, right? 2 cross 2 matrix. So how we will form that? So, this can satisfy, right? So basically, if you see here in this 3, so the first element of this, let's take as a AB, and let's take it as a CD, right? C and so in place of C, in place of A, sorry, what you can put? It is a first row and the first column. So if I just put it like that, 3, right? I put it 3, or if I can put it 4. So whether this 4 satisfied? No, it is not satisfied, because the row sum which is the first row is already 3, right? It cannot be greater than 3. It means I cannot put 4 here, right? I cannot put 4 here. So can I put 2 here, right? Yes, I can put it 2 here, but if I do put it, to put here random number. So basically, the problem with it is that if I to put here, I need to okay, let's see, if put a random number, right? I will put a random number. There's no process, I put a random number. So if I put a 2, this is less than 3 and this is less than 4. So this will become 1 and this will become 2, right? Okay. Now what is left? 1 left. So I will put 1, right? Okay, 1 left. So I will put 1. So the first row is 0. Now the second column, this is in second column 1. So this needs to be also deleted. So this will be 6. Now in the second row and the first column, what we need to put, right? Can we put, here 4? No, we cannot put 4 here, because the first column sum will be 4 plus 2, which is 6. But we have given only 4, right? We have left with only 2, so we cannot put 4, right? Also this 0 is also less than this 4, sorry, this 8 is also greater than 4, so we can put it according to the row. But according to the column sum, the first column is cannot be exceeded to 2, right? So it means I need to put less than 2, right? I need to put less than 2. So After this cd there is no element, so if I can't put one, because this will leads to only one, right? This will leads to only one, so I need to put it anyhow two here, right? So I will put two here and this will lift to six. And now in this element I need to put six and six here, right? So this, if you see, this satisfies the whole thing which is given, right? This satisfies the whole thing, 2 plus 1 and 2 plus 6. This is the one of the matrix possible for this 2 cross 2. But always we can we cannot always put any of the matrix any of the numbers at any place that leads, because that will lead to ambiguity, because we don't know na, because the reason is simply, the reason is because we don't the reason is that we don't know that in future what would be, what what would be the elements elements required to satisfy the row sum and the column sum, right? Because if you put random numbers, suppose I have put in two, instead of this two, if I put instead of this two only, if I put one here, that leads to be decremented. So this is only 2 cross 2, that's why it's get represented. But if you take this 3 cross 3, it will leads to some ambiguity. Let's see. So if you put, suppose this is 5 and this is 8, so we need to put less than this 5 and 8. Suppose I put 3 here, right? If I put 3 here, this will leads to, this will leads to 5, right? Again for this leads to, suppose this is 2 and this is 6. So suppose I put 1 here, so this leads to 1 and this leads to 5. Suppose I put again 1, because this is, we can't put less than greater than this. So this is 1 and this is 8, so this will become 7 and this is 0. First row enough. Now second row 7 and 5, right? We cannot put greater than this 5 or 7, so let's put at like 3, same. Again this 3 is here, so okay, one thing to note, this 3 is a fifth column, right? This 3 is in fifth column and this is seventh column, right? So this is needs to be 2 and this is 4, right? Again put it like 2, again this is becomes 2 and this become 3. Again put it like 2, and random number, I am generating random number, right? Why I am putting 2? Because this is the last element. Let's 2 and this is 5. Now when it comes to last part, see, we left it 2, right? So and this is the last, so we can't, we need to put greater than this, so this will be 2. Again this is 3 and this is 5. This again satisfied. So basically this is satisfying because we are not able to yeah, this is satisfying because we have just generated any random number, right? So basically some of, in some of the cases that will definitely leads to, that will definitely leads to some ambiguity, because we don't know that other process what we will left, what we will the left in the first process, because there is no any order we are following, right? So if we want to follow an order, that, so that I'm confirm, so that I'm confirm that I am definitely form a matrix that will that will that will that will satisfy the row sum row sum and the column sum conditions, right? Row sum and the column sum conditions. So one thing, if you see here, that what we were doing here in this previously, that we were checking the smallest number, right? We were checking the smallest number between this 5 and between this 8. Suppose I have I want to put in the first row, and the first column, this is the row sum. So suppose I need to put in the first row and the first column. So what we need to do, we need to check the first row and the first column, right? So this is 5 and this is 8, so we can't put greater than this 5 because this is the minimum element. So why don't we put 5? Because we can put any elements here, and there can be many possible matrix. So for confirmation, can't we put just 5? Yes, we can put 5. So if we put 5 here, this row, the some value would be 0, and this would be 3, right? If I put 5 here, in the next steps, this is 0, we don't have any elements, right? This is again first row, and this is the second column, right? So between this 0 and 6, we can't put less than this 0, so we will put 0 again. For same for first row and the third column, same for 0, right? Again, when we go to second row, this is 7, second row, and the first column, which is 3. So we can't put any number which is greater than this 3, because between this 7 and 3, this 3 is less than. So why don't we put simply 3? If we put simply 3, you note that this 3 will become 0, and this will be 4. It means that the first column is over, right? First column is over. Now we will check for second row and the second column, same for this 4 value. So 4 and 6, 4 is minimum, we will put 4, and we will simply make it 0 and decrease it to. Now, for the third column, in the for the second row, we can't put less than greater than 0. So we will just put 0 here, right? Now we will move to third row, which is 10, and the first column, which is 0. So between this, 0 is minimum, and and if you see 5 plus 3, which is already 8, satisfied with the column same, it means I need to put 0 here, right? We will move till third row and the second column, which is again 2. So this will be leads to 8. Now this 8 and this 8 is similar, all, and this will be 0, and this 8 and this 8 is similar, so we will put just 8. And if you see, we are definitely can form like this. And why I'm sure about that, because I'm just checking the minimum of between the ith row and the jth column, right? So what we were doing, the approach would be the approach would be that we will, for any particular cell, if any, for any particular cell, if any particular cell which is the matrix ith jth column, what we will do, we will check the between minimum value between the row sum I and the column sum j, right? That the ith row and the column sum j, and if any, which of the minimum, we will take that and minus it, right? And whichever will be minimum, we will assign to our matrix I j, and also we need to minus it, reduce it, or minus it, whatever you think, minus it, minus reduce from the row sum I and the column sum j, because we need to further check for the same row sum I and column j, right? Because this column j can be used further for the further rows, right? So that's what we do only here. So if you see, this can satisfy any equations, right? This can satisfy any of them, right? So suppose if I take any other examples, like let's take 5, let's take 7, 4, and 3, and also let's take, okay, one thing to note here that this row sum summation of row sum, summation of row sum must be equals to the summation of column sum, and this is given in our constants also, right? This row sum and column sum is also equal, so we don't need to check that. Otherwise, if it is not equals, we are definitely sure that we will not able to form this matrix, right? We are not able to form this matrix, so this needs to be confirmed for sure, and we have given the constant that this is similar, right? So the 743 is what 7 4 11 and 11 is 14, so we need to find, this is the row sum, right? This is row sum, and this is 14, so we need to take like let's take 5 6, and let's take 3, like same 4. Now what I'm telling, that I will just start iterating in cell j and cell I, and this we will check for the minimum of ith row and the ith jth column, right? We will check for ith row and the jth column, right? So let's do this, right? Let's do this. The columns of, so the first is first row and the second column, 5 is minimum, so we will take 5. It will reduce to 0 and this will reduce to 2. Same goes for this. Now 2 and 6, so 2 is minimum, 2 reduced to 0 and this is 0 and this is 4. Now again 0 is minimum between 0 and 3, so we will take 0. Now we will move to second row, first column. So if you see, the first column is already 0, right? And the second row is 4, so we will take 0. Now for second row and second column, this 4 and 4 both is minimum, right? So we will take 4. Now this both will be 0, right? Again for this third and third is 0, so we will take it as 0 and this is 0, and we will put what we sorry uh, yeah, for this 4, this is second row and the second column, so this needs to be 0 and this needs to be 0, right? Now we will check for second row and the third column, right? Second row and the third column, 0 is minimum, so we will just put out 0, right? Now we will go to third row and the first column, 0 is minimum, put 0. Third row, second column, 0 is minimum, 0. Third row, third column, 3 is minimum, 3 is put. So we will see this. If you see this, what we have done, we have the first row is 7, the second row summation is 4, and third row summation is 3. The first column summation is 5, the second row summation is 6, and uh, the third column is 3, which was before we have initialized it. So this is the process we will just follow for this. And yeah, this is the approach for this. So this approach can maybe come in your mind if you think like the smallest, we always need to take the smallest part, or if you choose a random number, you will face some issues for sure in some examples, right? So let's just start it. The row sum dot size, and will be column sum dot size. And let's, what we need to do, we need to form a matrix to assign the value, so that will be matrix that will initialize to this number of rows and the number of columns. So the number of rows and the number of columns. Now what we'll do, we will iterate in whole matrix to assign the values, right? So we will iterate in whole matrix, and what we need to do, we will check the minimum between the ith row sum and the jth column. That is what we will do. So we will check the row sum ith and the column sum jth. Whichever is minimum, we will just assign in our matrix, right? Also we need to reduce this minimum from row sum and the column sum, because we have already taken. So what we will do, we will just minus this minimum value. Same for the column sum, right? And at last we will just return the matrix. That's enough, right? That's enough. We will just take the minimum, we will just assign it and reduce it from row sum and the column jth, right? And we will just return the matrix. Let's run this. We have passed the sample case. Let's submit it. Yeah, we have passed all the test cases, right? So basically, what will the time in the space complexity? So time complexity is for sure O of n into m, right? Because we are iterating in whole array, right? So that will be definitely O of n into m, right? Okay. And the space complexity, so if you don't take this matrix as an extra array, and because we are returning this extra array as an answer, so that would be O of 1. But if you considering this extra array which is the part of the returning answer, so that will be O of n into m. But generally we don't take uh, the matrix which is a part of returning answer. So basically so that's why we are taking O of 1. But if you are considering the answer for results, so that would be open into them. So basically, if you see in the implementation, we are iterating for each and every cell, right? For each and every cell and checking for that. But we can do some further optimization, some slightest optimization in this implementation, and this will not move to overfan into m, but it will reduce to reduce to less than overfan to m. Let's see how we will do that, right? Some slightest modification we can do here. Slightest modification we can do here in implementation for time complexity, right? For time complexity, right? So what we can do, so one thing you see here, one thing you see here in the above example which we have taken, the starting was 7, the 4 and the 3, and this was 5, and this was 6, and this was 3, right? This was the rows and the columns were given, right? So one thing you see here, that if I initialize this matrix initially with 0, it means all summation was 0, all summation is 0, right? Initialize with 0, all summation is already 0. So instead of iterating in whole row and whole column, can we just iterate in the row which has some values and in the column which has some values? What does that mean? I mean that, see, what we are taking the minimum of 7 and 5, the first row and the first column. So we have taken the column sum becomes 0, right? Same goes for second, first row and the second column, 7 and 6, and this is 5, so it becomes 2, right? Same goes for first row and the second column for this. So second and 6 is minimum is 2, so we will just take 2 and reduce this 4 and 0, right? Now one thing you see here, that do we need to iterate in jth column again? Because row sum is already 0, it means I know that if my row sum is 0, I don't need to again see for minimum sum, because the minimum value can be possibly 0, and we have already row ith row is 0. So do we need to iterate in jth column, this third column? No, we don't need to do, right? So instead of iterating for each and every column, what we will do, we will just iterate and only that row that has some values greater than 0, right? So if I don't know, if I have 0 through a possible till second column, we don't need to move in the jth column because we have already initialized with 0, right? So what we will do, we will just take an I0 and J0, and we will iterate in while loop, and we will only increment our I and J if I have some value left in row sum or my column sum, right? That is what my motto is, that I will just iterate in the row sum and column sum if I have a value greater than 0, right? So if the row sum is 0, we don't need to if row sum I value has some value, so we will iterate in j, we will increment j, otherwise we just iterate move in the second row, right? So we will, the row sum till jth value is 2, so we don't need to move, sorry, this is 1 because we have started from 0, right? So this ith row, which is ith 0, is 0 now, right? Row sum is 0. So what we will do, this row sum is I is 0, so we don't need to move in j is equals to 2, we just move in I1, right? So this one iteration, is reduced, right? Same goes for this here, right? Now the first column and the second row, this 4 and this column sum is 0. So 4 is 0 0, right? We will move to second column and second row. The fourth row, 4 is minimum, so we'll assign this to 4. Same goes for, this 0 and this is 0. Now again the same thing, the row sum is 0, do we need to check for third column? Row sum is 0, we don't need to check for third column, so this leads to 2. So see, one iteration reduced, reduced, right? We move to 2th part. First third row, first column 0, third row second column 0, third row third column 3, right? So basically what we do, what we will check, we will, if 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 I have left row sum I value greater than 0, then we will only move to next column for that ith row, for that ith row. Otherwise we will move to next row. Simple, right? If I if we will otherwise we will just move to next row, right? If row sum is 0, because we have already analyzed with 0, so we don't need to check for further, because 0 is the uh, least possible value in the matrix, right? So initially, so what we will do, we will just take this initialize with 0, and instead of iterating in whole matrix, what we will do, we will just, okay, this, let's comment it out, and we will just take an value I0 and J0 and move till n and j less than n. And what we will do, we will check this for sure for each and everything. uh, let's, yeah, we will check for this for sure. But if this row sum I value is 0, then what we will do, we will increment I plus plus, otherwise we will just increment j plus plus, right? If the row sum is 0, it means we will move to its next row, because there's no there's no matter that how will that you move to its next column for check, because this is already 0 and we have already initialized with 0. So we will just move to the next row, otherwise we will move, if row sum value I is not equals to 0, we will just move to its next column, right? So if you see, we don't need to check for each and every other column, and this is the slightest modification we just need to do, and this is the same which we have done above, right? Let's just run this and see whether we are correct or not, right? Okay, some, okay, right. Let's run this. Premium. Okay, we have passed all the test cases. Let's submit it. We have passed all the test cases, right? So basically, we have just optimized further, which is less than O of n into m for sure, right? This is Cyrus modification, so which is definitely is less than O of n into m, less than O of n into m. And the space complexity is same. If you consider the matrix answer as a extra, then you will take you will consider O of n to m, otherwise O of 1, right? So this is how we will solve this question. Hope you understand. Thank you so much. Bye bye.